So lots of things are succeeding that did not succeed before, including lots of on-chain things, right? And not just things that try to like completely hide the blockchain from the user and like act like it's this like shameful thing you're supposed to like put somewhere in the back corner of the dish, right? And I think we're seeing a lot of success, right? And so the question is, well, what do we need to do to actually take the next step? So the way that I think about this question is I first think about the goal, right? And the way that I think about the goal is like this, right? I think there's basically historically been these two types of software that we've seen. One type of software basically sacrifices decentralization for practicality, right? And this is like most commercial software, it's like most software that most people use by default. And it gives a good and improving user experience, but it sacrifices decentralization, and there's lots of important edge cases where it really, really doesn't serve the user well as a result. Now, on the other side, you have applications that sacrifice practicality for decentralization. And this happens on two dimensions, right? The first dimension is you have applications where just the technical properties of the application end up really sucking because they take like lots of hard trade-offs to ensure that everything is fully decentralized, fully serverless, and so on. And the other dimension is like something much simpler, which is basically that decentralized things and things that treat their users with respect are harder to monetize, and as a result, you're not able to like push the features and the UX up to the same standard of quality. There is this very long tradition of pre-blockchain decentralized software and pre-blockchain open source that totally falls into the second trap, and there's lots and lots of software, I think including, unfortunately, lots of applications in the crypto space that fall into the first trap. I think as an ecosystem, we should reject both of those traps, and we should even reject the trap that we need to like bifurcate and create like the niche nerd ecosystem that's decentralized, and then the normie ecosystem where like actually everything has to like go through trusting like Google and AWS for everything, and we need to like actually do the hard thing and take both. And I think there's lots of technologies that we have available that mean that we actually can do this. So we'll talk about practicality first, right? So what are some examples of practicality that the ecosystem still needs, right? So one of them is more scale. So today, transaction fees are less than 1 cent. But today, the amount of blobs that are being used by layer 2s is basically exactly at the target. And because it's exactly at the target, that basically means that it's not able to actually scale more without increasing costs for users and pricing out certain low transactions. Now, that's not entirely true because actually, as I'll talk, there's a lot of unclaimed ways for L2s to use data more efficiently. But it's like roughly, we haven't won permanently, right? And so we still need to improve scale and especially improve scale at layer 2. Shorter confirmation times. So 12-second slots are competitive with credit cards, but credit cards suck, and we should not be competitive with the thing that sucks. We should be competitive with the centralized thing that's good. And so we want shorter confirmation times, realistically, shorter than 2 seconds for important confirmations to happen. Cross layer 2 interoperability. So today, bouncing between different layer 2s feels like you're bouncing between different blockchains. You should not. And then user account security, and so I'll still talk about some aspects of this, and I think this example is one of those things that's like really at the core of being decentralization friendly and next billion friendly at the same time, and so we'll talk about that too. So let's talk about more scale. So for more scale, this is approximately on the left the plan for what L1 aims to do over the next couple of years. So, of course, everyone's probably heard of Justin as saying 2029 for the completion of the full lead chain. I think it's really important to clarify. 2029 is the intended date for when everything finishes. We're going to get the scale much sooner, right? So basically the next step is to implement PeerDAS, and PeerDAS will get us from about 3 to 4 kilobytes of data per slot to about 1 to 4 megabytes per slot, and then eventually full DAS, which will get us to 16 megabytes per slot. And on the other side, there are improvements that Layer 2s can make to implement data compression, where if you take all of the ideal technologies and stack them together, you can go down from about 180 bytes per transaction, potentially all the way to 23 bytes per transaction. So this is also a 7x. And I think most of this so far has been relatively unclaimed. And I think one of the reasons why actually is because everyone has been using ECDSA signatures, and ECDSA signature is 65 bytes. And so if you do like everything else well, but then you still have an ECDSA signature, then your 23 bytes goes up to like 85 bytes, and like instead of a 0.9 order of magnitude improvement, you have like a 0.3 order of magnitude improvement, and that's like not very interesting, right? And so I think aggregation and really we're actually making a little bit further. Right? But more scale is one of those things that's really important. Shorter confirmation times, right? So I see basically 2 classes of techniques that can do this in the short term. So one of them is L2's you having sequencers, which they do already. Though one of the challenges, of course, is that they're trusted sequencers. We need to make them provide stronger trust guarantees. And the other strategy is basic rollups plus L1 pre-confirmations, which is a space where there's actually a lot of work that's started already. Now, in the longer term, I think we'll be able to get the single slot finality and also push the slot time down quite a bit. But that feels like relatively a more long-term thing. Pre-confirmations feel like a somewhat shorter-term thing. And so I think on L1 and on L2, we can keep reducing confirmation times by quite a bit. Cross L2 interoperability, right? So I think this is one of those problems that has both a short term and a long term. And for me, the goal is basically that moving between the L2 ecosystem should not feel like you're moving between different planets. It should feel like you're on Ethereum. And so one of these examples is new address formats. So the address should just include which chain you're on, and if you take one of these addresses and you put them into a wallet and you click send, the wallet should just automatically interpret your send as a request to go through a cross L2 bridging protocol like ERC-763, and basically you that protocol already can actually do optimism to Arbitrum, at least for relatively low value events, which basically means non-millionaire amounts in 2 seconds, right? So technology's there, it just needs to be really deeply integrated in the UX. Longer term stuff, general purpose cross layer 2 messaging. So I think these intent-based bridging protocols, they work for very common assets that are very high volume. They work less well for rare assets, and they definitely don't work at all for NFTs. Because how do you even run liquidity for an NFT? That's hey, I have the Vitalik value, and that means you also have a copy of the Vitalik value, and you use that to front run liquidity. This doesn't make sense, right? So just actually very well standardized across L2 messaging. Also potentially also more complex interops, so doing things like shared sequencing, which will enable a lot of the financial operations happening more effectively. So there are all of these things that actually can be done, and they're already starting to be worked on. So user account security. So the way that I think about user account security is in the crypto space, we've basically been stuck in this trap between 2 extremes, right? And so the 2 extremes are, on the one side, you have the maximalists, who are you need self-custody, you need self-sovereignty, you need to hold your own private key, and then you write down your private key on a 12-word sheet of paper, and then you take that 12-word sheet of paper, then you engrave it in titanium, and make sure that it's fire resistant, and you put that in a safe box, and the safe box can be made out of tungsten, and then you take the tungsten and then you lock it up and you push it 19 feet underground. No, wait, sorry, we're not in the US. You push it 19 meters underground, and then it's going to be safe, right? And you have like people who like literally make blog posts that basically say that, right? And then what happens on the other side is you have a bunch of people who just say like, screw you, this sounds like a nerd hobby I don't even want to get into, or I'm afraid I'm going to get screwed up. And they basically say, well, this stuff is annoying. Instead, I'm going to take all my points and I'm going to put them into a trustworthy, centralized exchange that's run by trustworthy founders who are vegan and donate to altruism and who go on panels with Go. Now, the challenge, of course, is that then 2 years later, one of these founders might end up having financial relations with your assets, and of course, basically your money ends up being gone, right? And so, I think we basically don't want either of these, right? And I think there's actually a very strong roadmap to getting something that combines the benefits of both, that protects you from your own mistakes and that protects you from centralized bad actors. So those are practicality rules, right? So let's talk about decentralization rules. How do we achieve all of these things in a decentralized way? So the strategy for scale on L2 is data availability sampling, right? The basic idea is you have these blobs of data, and instead of downloading the entire blob, each node only needs to download a small portion of each blob, and the blobs are erasure coded, and there's math that happens in the background that basically ensures that even if up to half of the blob disappears, the other half of the blob can be used to recover the rest, right? And so, it's like one of those Borg cubes from Star Trek, right? You can damage anything up to I think in Star Trek it was you can damage all the way up to 73% of the cube and it can heal itself, right? It's exactly that sort of thing, right? So data availability sampling, basically each client only needs to download and sample a small portion of the block, and there's a one-dimensional version of this that is doable short-term, and then there's a two-dimensional version of this that is doable relatively longer term. So this way we actually get a decentralized network, and basically that has some of the properties of being a peer-to-peer network in the sense that if you think about BitTorrent works, BitTorrent does not require every user to download every file. It's a highly distributed system, different users store different files. So if we want to scale, we need to figure out how to do that same thing, but with consensus blockchain guarantees. Data availability sampling solves that exact problem. So that's one piece. Now, let's talk about shorter confirmation times, right? So I think there's a couple of strategies. So one is L2s will centralize sequencers. I think are okay for some apps, right? So I saw, at this event, there was an entire gaming section. Lots of people were excited about gaming. So, so here is World of Warcraft. Okay, it's the one game that I've properly played, except for games that I coded for myself when I was a teenager. So, in World of Warcraft, you have this latency bar, right? And the latency bar, when the latency is less than 300 mils, it's green. When it's between 300 mils and 600 mils, it's yellow, and when it's above 600 mils, it's red, right? Okay, so if you remember, in World of Warcraft, trying to fight any kind of actually hard monster, or even doing PvP when the latency is red, when it's above 600 mils, right? It sucks, right? You die very easily. So the challenge, and World of Warcraft itself, explicitly tried to be casual friendly and tried to make extreme low latency not matter, right? And so the challenge is, of course, that a decentralized system, I think, basically has no way to get less than 600 mils of latency and at the same time stay decentralized, right? It's okay, you can build up the crazy infra and you can do the math, theoretically, one side of the world to the other side of the world, that's 20,000 kilometers, divided by speed of light, that's 67 mils. You need 3 rounds of consensus, and then 200 mils. But that's an incredibly fragile efficiency maximizing approach. That's not at all appropriate for an actually robust and decentralized blockchain, right? And the problem is that not only do you want to make decentralization possible, you also want to make sure decentralization is not overly economically penalized relative to extreme optionality, right? And so we actually want pretty big safety factors. So decentralization is not going to offer the best experiences for everyone, and so I think for that reason, layer 2 centralized sequencers are okay for some applications, and then of course you have layer 1, layer 2 decentralized sequencing, And then the other approach is layer 1 pre-confirmations, and that can be done in like a centralizing way, or it can be done right. And I know there's a lot of teams that really wants to do it right, and so this slide is taken from one of Justin's research posts. So that's one of the directions. And then the other direction is like actually like super optimizing the Ethereum consensus loop, and basically trying to make the peer-to-peer as optimized and as unwasteful as possible. So I think we have both of those approaches. Cross L2 interoperability, so if you want to keep it decentralized. So I think, for me, the way that I think about this is that for interoperability, it's like moving between cities, right? And like, if you're a country, then you're going to want to provide at least some specific method of moving between cities as a public service, right? You have the cars, you have the private helicopters for like, the Taylor Swifts of the world, or I forget, maybe she was a plane, and like not too into this stuff. For everyone, but then for everyone else, like there is a highly robust subway and bus system, and at least it's always there, even if you can't afford the other thing, or even if the other thing like suddenly goes bankrupt, right? And so, to me, like the equivalent of this is that the Ethereum ecosystem needs to have an always available, totally decentralized, non-single party dependent protocol that people and applications will always be able to use in order to move assets from one L2 to another. And for me, like ERC 7683 satisfies that goal, right? And I think there are going to be specific situations where individual tokens might be able to optimize on top of that. So like if you're using USDC, you trust USDC already, you might as well just let that like in-sub-bridge for you. And then like individual layer 2 ecosystems might have like direct movement that's about as fast. So sometimes you can improve on it, but having the baseline is really valuable to me. So that's one. Likewise. So Likewise, basically, he wants to be able to actually verify what's going on L1 or on L2 in a mobile wallet or in a browser wallet without having to trust an RPC. And there's work that's being done by the Helios team, which is actually pretty close to actually letting us do this. Shared bridges, so this is technology that basically would allow a token to be stored in a structure that is owned by multiple L2s simultaneously. That makes it really easy to do batch transfers between them. And so in the far happy future where every L2 is a ZK rollup that's committing to Ethereum memory slot, then you're going to be able to also do native liquidity provider free asset movement from one to the other in one single slot, which is probably the best that we can do. And then also for base rollups, we can do shared sequencing. Right? So there's a lot of good things that we can do in terms of cross-L2 interoperability. Let's talk about account security. So this is one of those things where I think there actually is an opportunity to build something that works for new users and for experienced users at the same time, right? And the way that I think about this is I think about this with guardians, right? So for your account, realistically, what you want is you want like a key on your device, and then that key alone can authorize low-risk operations, right? So with your crypto wallet, you should be able to like tap to pay $25, but you should not be able to tap to pay $25,000, right? That's the wrong convenience versus trade-off. Then, if you want to do more intensive operations, or if you want to recover your primary key, then you have some collection of things. For a starting user, possibly one, but then ideally go up to some collection of several of them. And these guardians could be your own physical devices, so hardware wallets. This could include friends and family, so either their Ethereum addresses or things in this whole category that are owned by them. It could also include institutional guardians, which include specialized services, and the big unlockness here is ZK wrappers of existing services, right? So the way that I think about this is that for in the Unix philosophy, text is a universal interface for communication. In the Ethereum philosophy, an ETH address is a universal interface for authority. If you want to make something that is controlled by an email address, you use ZK email, and you can generate an Ethereum address, which you can only spend from if you control that Ethereum address. And thanks to email TKIM signatures plus your knowledge proofs, you can actually do this. You can also make a similar wrapper around any kind of government digital ID. You can make a wrapper around passports. You can make a wrapper around with a TLS notary, any other Web2 service. And so basically you can turn almost any existing root of trust into an institutional holding. Right? So there's a lot of interesting different alternatives here. Now, so the vision that I want to see, right, is so this is like a mock-up, right? Imagine a version of Gnosis Safe where you can basically set up your guardians, and then you have like a bunch of fields, and you can stick an email address in there, or you can stick an Ethereum address in there, or you can stick like a government ID number in there, or you can stick a Twitter account in there, and it just automatically under the hood converts each of those things into an Ethereum address, and it just generates you a multi-sig, which is like actually in the backend controlled by employees, right? And so how do I envision this being used by actual users? So imagine you're a new user, and you decide, hey, I'm tired of Twitter, I want to move to Farcaster. So what does Farcaster do already? What Farcaster does already is it actually sets up an in-app wallet for you, generates a private key. With that private key, you can sign things inside of Farcaster. Inside of Farcaster, in the Advanced tab, there is already an option to change your recovery address from Warpcast centralized recovery to any arbitrary recovery address of your choice. This is something that you can just already go and do. Now, and then, what basically I think what we could do is like that, but for every application, right? If you're a new user just coming in, then you should not need to already have an Ethereum wallet to download your application. But if you do have an Ethereum wallet, you should be able to easily link any application to your Ethereum wallet, and it should have all of the benefits of like basically acting as part of your Ethereum profile, but at the same time, like you keep that separation, and potentially you even keep the link off chain, and you do things with stored knowledge proofs, and so you even have greater privacy density, right? So, and then potentially a user would start off with the only guardian being either their email address or the service, and then over time, as they have more applications and as their profile becomes more mature, they would be able to just upgrade their security setup over time, and then they very easily just turn their account into a multi-sig with whatever participants they want. So I think basically we can create a framework in which new users get something that's very user-friendly for new users. Existing crypto users get things where they can just put in the same 12-word seed phrase that they're already comfortable with, and it becomes very easy to switch from one to the other or a combination of the two. So to me, this is like the best bet I have of actually practicality for the next billion, and at the same time being friendly to users using the ecosystem in a decentralized way, in a way that they're actually still participating in all of the same playing fields. So, summary, right? I think we can make applications that are mainstream friendly and decentralization friendly at the same time. And I think many tools for this already exist, and I think lots of other tools are under development. Some of these challenges are user experience account abstraction challenges. Some of these challenges are layer 1, layer 2, blob, pre-confirmation scale challenges. Both of them are really important. And I think layer 2 teams can do a lot to help, both in being the best layer 2 that they can be and providing speed and scale, and at the same time making sure that they're aggressively progressing to stage 1 and stage 2, and actually preserving the L1 decentralization. And at the same time, also actually doing all this excellent work of actually bringing in and appealing to all kinds of developers and users. So thank you guys all for your hard work, and look forward to this continuing.
Thank you. Can I take some questions? So, if you take some questions, you have about 5 minutes left, so if you take some questions, please raise your hand and then you'll take a selection from there. And then you'll have mine. There's one behind you.
Hi. Thanks for sharing the topic. Have you considered using more advanced erasure coding for things like historical expiry, state expiry, etc. on the source side, and exercise of the data, as well as for the transmission of the data, whether it's for pre-com or peer-to-peer network protocol networking.
Yeah, I mean, I think my view on that is like switching the erasure code is relatively low value compared to other things, and like we already have an erasure code that works very well. And I think there's a lot of just efficiency and convenience benefits from just using the exact same code across the stack, right? And so for things like state expiring, like history expiring, what I favor is basically just putting everything into blobs. And blobs already have a really nice, really clean working implementation of like de facto erasure coding because it's they're all polynomials and they're read-only code. And you basically use the exact same infrastructure to do a shortened history storage as you use for data availability sampling. I think that in the longer term, we will have to upgrade from KCG blobs anyway because like the current KCG-based setup is not quantum resistant. And so I think there is a longer-term opportunity to upgrade to something else. I mean, I think like looking at the erasure code is one of those things that's worth thinking about. Though I think it's also worth like appreciating just like the simplicity and beauty and legibility of just using polynomial evaluation. So for me, like I think that's a discussion for I think like the 5-year roadmap. Like I think from now, blobs as we have the portfolio.
Do you have any more questions?
Talking about blocks, do you have in mind the specific limits in terms of storage and in terms of bandwidth? Specifically from the point of view of solo stakers that are now very vocal on Twitter on the minimum requirements?
Okay, so let's look at the roadmap. Let's say long-term roadmap, full data availability sampling, 16 megabytes of slot, right? So that gives the entire blockchain a bandwidth of 1.33 megabytes a second. And so if you have a node that wants to like fully store everything, then of course for here that's going to turn into 1.33 times 32 million, and so you're going to get about 48 terabytes per year, right? Which is like definitely doable, plus the proof would be like less than a kilobyte in size. And so if all of this is implemented correctly, the raw amount of information that you have to download will be about 50 kilobytes a slot, right? So it's extremely possible to do a very performant blockchain with huge amounts of data, but only impose a very small load on each individual participant. Now, that's obviously not like the status quo today, right? The status quo today is like, if you increase the block count, then that means that either like solo stakers have to process more data, or it means that we have to figure out some efficiency improvements on the peer-to-peer side, which I think actually might be possible, right? Because as I said, right, blobs are already natively erasure coded. Erasure coding is actually one of those strategies for optimizing peer-to-peer already. Maybe there's like something quick that can be figured out. But in the long term, I think it's like the sampling approach, if you do the math, actually is very data-light on individual nodes.
Even for upload?
Even for upload, yes. I think, the statistic for like 50 to 80 kilobytes that would be download and upload. I mean, probably the closest thing to an exception would be like the block building process. But then for block building process, like two answers, right? One is that as a client, you can always not participate in block building. You can only do like inclusion list and attestation responsibilities. And the other answer is that you can do the there are designs for distributed block building where you would not you would need more than 50 kilobytes. You would have to download and upload potentially a megabyte in a slot, which is actually pretty comparable to at least the worst case of what you have to do today already.
Since no one has asked it, what are your thoughts on the chain proposal?
Yeah, I think the core ideas there, right, I think align a lot with ideas that I've been talking about all along, right? So I think the core ideas are all correct. I think the one thing that I personally think we need to be careful about is I don't think we should go too fast into reckless in reducing the swap time of the L1, right? Because as Phil said in his presentation yesterday, for Ethereum to be decentralized, it needs to be geographically fair. And if we try to hyper optimize Ethereum for as short swap times as possible, then stakers in Latin America, Southeast Asia, Africa will be disadvantaged compared to stakers that are very close to very unclaimed peer-to-peer optimizations that could improve the laws to help stakers in those regions, right? So, but other than that, I think all of the ideas make sense. I think the one thing that's really important to keep in mind is that there is this trade-off of doing those ideas in an all-at-once fashion versus doing it in a more incremental fashion. And there's actually a lot of debate among core developers about which approach is better, right? You can think the benefit of this all-at-once approach is that it's very good at bringing in new people into the consensus research process, right? And I think a lot of people here would be, if you show interest in participating in a beacon chain redesign, even if you haven't done beacon chain stuff before, it would be very welcome, right? But then the other side is that actually doing bigger changes can be risky. And so I personally expect we'll see some combination of both. And I also expect that, as I said before, right, the roadmap time for completing the full thing and creating this maximally ideal, platonic, beautiful Ethereum chain is 2029, but you're going to get lots of very, very important upgrades long before that, right? So this full data availability sampling roadmap, I think, if people put their mind to it, can be done in 2026. And earlier steps can be done even earlier. And then also, same thing for the right side of this. Seamless functionality, I think, can potentially be done in a similar time frame. Potentially, statelessness can be done. I would say it's probably worth doing it a little bit later and focusing on seamless functionality and ETH improvements and then in TDS first, right? But huge amounts of very important things that are needed to actually complete the underlying goal of getting to 100,000 TPS in a way that's on-chain and that respects decentralization and openness and permissionlessness. I think that can be done much sooner than the full 2029 period.
Okay, one last question. Okay, one last question.
For interoperability with alternatives to standards, yes, we absolutely do. And there's lots of groups working on those standards right now.
Thank you very much, guys. Thank you.